Welcome back to Knowledge Hub. What keeps space empty? Space is not empty. A point in outer space is filled with gas, dust, a wind of charged particles from the stars, light from stars, cosmic rays, radiation left over from the Big Bang, gravity, electric and magnetic fields, and neutrinos from nuclear reactions. As the book, Nothingness, The Science of Empty Space, by Dr. Henning Jens describes, space is also filled with two things we can't directly detect: dark matter and dark energy. Even if all these things could be removed and blocked out from a certain region of space, there would still be three things we could never remove according to Dr. Jens' sad face: 1. Vacuum energy, 2. The Higgs field, and 3. Spacetime curvature. Vacuum energy, also called vacuum fluctuations or zero-point energy, is a sea of particles and antiparticles flashing briefly into and out of existence. Vacuum energy has a very real effect because it weakens, or screens, electric fields. Vacuum fluctuations are not some exotic, untested, theoretical artifact. Rather, vacuum fluctuations are fundamental to many everyday phenomena. Lasers, like the one in your DVD machine, crucially depend on the existence of vacuum fluctuations. A laser beam is created when you set up a material properly so that you get a chain reaction of coherent light emissions. This chain reaction is started by vacuum fluctuations. Likewise, radioactive decay, such as experienced in the carbon-14 that archaeologists use to date materials, is initiated by vacuum fluctuations. Vacuum energy can be measured through the Casimir effect. Two uncharged metallic spheres are brought very close together and the vacuum energy causes them to be attracted. When their separation is small enough, the attraction due to vacuum energy dominates over gravitational and electromagnetic effects. Vacuum energy also accounts for the Lamb shift in hydrogen energy levels. Vacuum energy is an established principle of mainstream physics. On the other hand, harnessing vacuum fluctuations as a free source of industrial energy is pseudoscience. Next, the Higgs field exists everywhere and is what gives many particles their mass. Due to the conservation of mass energy cannot be created or destroyed in a closed system. As a result, when the Higgs field gives mass to a particle, it does so by taking energy out of the vacuum. The Higgs field made big news in 2012 when the first significant experimental verification of its existence was announced at the Large Hadron Collider in CERN. Lastly, spacetime curvature is an innate property of space itself, according to Einstein's general theory of relativity. Masses act on space by giving it curvature, and space acts back on masses by having them travel in its curved shape. The phenomenon of masses traveling in straight lines in a curved spacetime is known as gravity. The curved trajectory of a satellite in orbit is really a straight line in a curved space. A space devoid of masses still has a shape. It still has Einstein's metric field. That shape can even be curved, even without any masses, according to the equations. There is no way to suck gravity or block gravity out of a region of space because gravity is just the shape of space itself. As a result, even the most empty of physical vacuums will always have a curvature field. Perfectly empty space will always have vacuum energy, the Higgs field, and spacetime curvature. More typical vacuums, such as in outer space, also have gas, dust, wind, light, electric fields, magnetic fields, cosmic rays, neutrinos, dark matter, and dark energy. Despite all these things zipping around in outer space, space does seem empty to Earth-bound humans who are used to a dense layer of air to swim around in. Thanks for watching.